Okay, we're going to look at continuity and limits. A continuous function has a graph that can be drawn without lifting your pencil from the paper. There's various ways that a function can fail to be continuous like this everywhere. First function we're going to look at is graph of y equals 1 over x. If you go onto your calculator and graph out this function, you're going to see that it has this shape to it. Okay, so the questions ask, what happens to y, our graph, as x approaches 0 from the left? So if we're coming from the left here, meaning this way, as we keep going here, what happens to our graph? It keeps decreasing and it goes down to negative infinity. Next one, what happens to y as we approach from the right? So as we keep coming towards 0 from the right, what happens? This is going to keep increasing, so it's going to approach positive infinity. The way we write that in math is with this notation that says the limit, LIM, the limit as x, this line here means approaches 0. Of the function here, 1 over x is equal to negative infinity. And we saw from the other side that the limit as we approach x equals 0 from the positive side, that's what this little plus indicates, just as this little negative indicated from the left, equals infinity. Be familiar with that notation as it'll come up as we go through some of this limit stuff. All right. So looking at some graphs then, consider this function. What happens to our graph y as x approaches 0 from the left? We can see from up here that from the left, meaning from the negative side, as we approach 0, there's not a point there, but it looks as though it should be approaching a y value of 1, and so we would indicate that this is 1. What about if you approach 0 from the positive side, from the right? Well, here it does have a point, and it looks like the y value there is 3. So that's how we would fill something like that in. All right. On this example, why don't you pause and try this one out for yourself. All right, let's see what you got. What happens to y as x approaches negative 1 from the left? You should have gotten here that as it approaches from the left, it keeps increasing towards this asymptote, and so we should get infinity here. And then as it approaches from the right, you should get positive 2. There's no point there, but it looks as though it's going to hit the y value of 2. All right. This one, if you don't have a specific value here, as here you can see it's a, we still have a indicated on the graph. We can still answer that as y approaches a from the left. It looks as though the value is 2. As we approach from the right, it also looks like the value ends up being 2. And so there they are the same.